Dear students, today we will learn about matrix. In that matrix, we will learn properties of determinants. So the following properties are proved for determinant of third order, but they hold good for determinants of any order. These properties enable us to simplify a given determinants and evaluate it without expanding the given determinant. First property, the value of the determinant remains unaltered if the rows are changed into columns and columns into rows. So if we found, let us see here, the matrix determinant is a1 b1 c1 a2 b2 c2 a3 b3 c3. Consider its value as a delta, and if we interchange the rows, again we find out the determinant is unchanged. So you can try taking the numbers as elements. You can check also, verify. Second property, if two rows or columns of a determinant be interchanged, then the determinant remains its absolute value but changes in sign. If in a determinant matrix two rows are interchanged, the value is become changed, that the sign of the value is value of the sign is changed, because if the before the interchange the rows are columns, if it is a positive value, after the interchange we will get negative. So this is, you can apply with numbers also. Next, third property, if all the elements of a row or column of a determinant be multiplied by a common factor k, the whole determinant gets multiplied by k. So suppose if the determinant of the matrix is 5, if you multiply with 2 for any row or column, then the determinant becomes 2 into 5. You can apply this for numbers also. If two rows or columns of a determinant are identical, then its value vanishes or is equals to 0. That means if two rows are equal, then its determinant is 0. Next, if each element of a row or column of a determinant consists of the sum of the two terms, the determinant can be expressed as the sum of two determinants of the same order. For example, here see the third row, a3 plus l, b3 plus m, c3 plus n, and we can split like these two determinants, a1 b1 c1 a2 b2 c2 a3 b3 c3, plus remaining two rows are same, a1 b1 c1 a2 b2 c2, and the last row is l m n. So like this we can write. And the last property here, this is the important property we mostly use to solve or to show the given result. If to each elements of a row or column to be added or subtracted equi multiplies of the corresponding elements of one or more rows or column, the determinant remains unaltered. See here, for first column we are multiplying with p to the second column, and we are multiplying with minus q to third column, and after that we are adding to the first column. So still the value of the determinant is same. So this property is very useful for simplifying determinants. To add or subtract, multiply rows or columns, we shall employ the following notation. Suppose to the elements of second row we add p times the elements of the first row and q times the elements for the third row, then we say operate r2 plus p r1 plus q r3. So these are the properties of determinants. We use these properties to get the determinant value of a matrix. Some more also there, but here we are using 6 properties. So see the examples, try to do exercise problems. Thank you. Have a nice day.